All right, so area under a curve. Basically what we're doing is using, at this point in your development, in geometric terms, you have a whole bunch of different ways to calculate area, right? You can do rectangles, squares, circles, and on and on and on and on, right? Okay. The next step is to be able to calculate an exact area under a shape that curves. Okay. And that is the focus of what we call integrals in calculus. Okay. We start out, how I'm going to start you today, estimating or approximating. Okay. So we're going to start with approximating it with either rectangles, trapezoids, rectangles or trapezoids. You might throw a triangle in there once in a while, okay? But that's only just looking.
Later, because a lot of curves are infinite, will we be creating functions that gives you the area as the continuous function proceeds, or will we always have those?
In AB, all you deal with is intervals and defined areas. Okay. In Calc BC, we move to infinite. They're called improper integrals. Okay. So don't worry about that too much. That's part of this. Okay. Yes. So the area, this is the area between the curve and the x-axis. In this case, interestingly enough, it's positive. Okay. It would be negative. I think you've always been taught negative is not possible for area.
Okay.
It's not, it's only negative because it's denoting it's below the x-axis. It's kind of a location indicator. Okay, so we're not going to deal with it this year, but that's called sine area. Okay. So that's what we're looking at. So if I had this function, I would be able to estimate the area using rectangles. And you can see that it's not precise, right? But I can still have an approximate answer. So let's go ahead and do one. I'll use the square root of x again. Square root of 4 is 2. 1. So. that would be something that you would have to interpret there. That's kind of a problem statement. So, we're going to use 4 rectangles, and they have to be what's called right in point. It means it's on the interval 0 to 4. Okay, so we're going from 0 to 4, right? And we're starting on the right side. So when you draw your rectangles, you start on the right side. See how that works? The question is, how big are your rectangles? How tall is this rectangle? Yeah, square root of 4, right? Because that's the function, it's the square root of x, which is 2, right? How wide is it? 3 to 4 is 1 unit. Thank you, Dominic, for that. Okay, in fact, all of these are 1 unit wide, correct? Okay. How tall is this one? So it tells you this right now. Okay, this is where you have to be precise. Okay, 1 3/4 is not good because that's an estimate still. You got to use the function. It's the square root of x. The x value is 3, so the value is square root of 3. So how tall would this one be? Yes, root 2. This one, square root of 1, right? And now add, calculate the areas. 1 times 1, 1 times root 2, 1 times root 3, 1 times 2, right? Now, if you're on a pre-responsive calculus exam, this is where you stop. Okay? Because this is numeric answer. We're not testing your arithmetic abilities. All the calculus is done, you're done. Okay, so there's a little carrot for you next year. I want you to finish them because you will have multiple choice questions that you have to calculate the actual decimal, right? So 1 plus 2.
So the first responses are only asking for the calculus portion.
Basically. Yep. You get a numeric answer, which that is. You can finish it, but again, you're buying 3 hours in when 8 exams, like, what's 1 plus 2? 4. Right? So stop. So this would be perfectly acceptable numeric answer. Does anybody have a decimal? If it is calculator friendly, 3 decimal places. You don't even have to round properly. Okay, you can truncate around.
Wow.
So we're good there? Yeah? Okay. Let's do y equals x squared. We call left endpoint rectangles. You don't keep the volume down to touch. Stats folks. Okay with you chatting. Keep the volume down. Thank you. What's our interval? Let's go -2 to 3. And 5 subintervals. So -2 is here, right? All the way to, all right. Be careful of declaring that. People have been knowing the Oliver did. Recorded in this book. Oops. My graph's gonna be a little off. Nine three, nine's gonna get this. It's actually not gonna matter. That's the only part about it. I'll show you why. Okay. Okay, so here's our graph from -2 to 3, right? And we're gonna do left endpoints. So where does that start? On the left side, right? Correct? On the left side. And there are 5 intervals. So 1, 2, 3, 4, 5. There's one interval. There's another one. Okay. Does this actually have any height? No, it doesn't. If you start on a 0, it's 0 tall. Okay. Then this one's left. And this is why the 3 doesn't matter. Because we're now to the end, and I don't have to go all the way. So building from left to the right. Those are your left endpoints. One other way to think about this is it's the top left of each one. Okay, let's do our math. How wide are these? Yeah, they're all 1 again. Thank you, Mr. Arthur. How tall is that? 4. It's x squared. -2 squared is 4. 1, 0, 1, 4. Yes, and this one you don't need because it's the rectangle's already covered that area. So. You have to write this down. You know why?
Because you get the answer.
You get 1 point on the AP exam for that. You can still get the answer, but that is the point. Can you write out an addition multiplication problem? Yay! You just earned a point. Okay? So yeah, you do need to write your work down. Why have I been stressing that all year? Right? Are we good there with left? Good. Okay. One more, and we're done. We're going to use midpoint this time.
Right.
Let's just do y equals x from 1 to 3. 4 subintervals. And midpoint